Let's start linear motion questions. Okay, take your tutorial. So we did few questions, no? We did few questions. So we need to do more questions. Okay, before that, see motion under gravity. See motion under gravity. See this and all. You consider here there's a particle. Here there's a particle. I'm going to release this sun somewhere here with initial velocity 0. Sun that move along a vertical line, no? That move along a vertical line. So that motion we call motion under gravity. So you consider same particle we're going to project downward with velocity u. Then definitely it go downward, no? Along a line. Again, motion under gravity. So you consider here a particle that move upward with initial velocity u. So it goes like this. It goes like this. So here upward motion, then it turn to downward motion. Turn to downward motion. So anyway, here all motions we say motion under gravity. Motion under gravity. So motion under gravity means always gravitational acceleration downward g. That object has always the gravitational acceleration downward g. So here g usually we take 10 meters per square seconds, or sometimes we take 9.8 meters per square seconds. Otherwise we generally take g downward. So when particle moving upward, it has retardation, can reach maximum height. Then downward motion, its acceleration g downward. So anyway, here this is gravitational acceleration. So when you project this type of particle upward, then that motion linear motion under gravity. So if you project that one with some inclination, that motion like we call projectile motion. Here vertically upward, no, then motion linear motion. So when you consider this type of linear motion, it has maximum height. You consider here the particle upward motion u, it has maximum height. Then at this maximum height, its velocity 0. Then further it can't move, no? Further it can't move upward. Velocity 0. V equals 0. Maximum height. So here when it comes to same level, it velocity downward u, because energy will conserve, no? Then upward u, then downward u. So you consider some level here, a horizontal level. So that level pass upward motion and downward motion, both case it pass. But maximum height only one place. Maximum height at one place. Then here upward, downward, there are two cases. Here time t equal t1, here time t equal t2. Time t equal t1 and t equal t2. There are two cases. Okay. Then here maximum height only one position, but some level below that there are two different times. Anyway, each case downward acceleration g. So we know when we are doing velocity, when we are sketching velocity time graph, here time, this is velocity, no? Here first quadrant, here fourth quadrant. Then here first quadrant we say positive directions, and fourth quadrant we take for negative directions. Okay, positive direction first quadrant, negative direction fourth quadrant. That's the thing. So when you consider upward motion positive, then initial velocity u upward, no? Then here u upward positive. Then it goes velocity decrease in format, no? Then retardation. Then here the maximum height, velocity 0 level, here maximum height. Then its retardation tan alpha given by g. tan alpha given by g, g given by tan alpha, no? Therefore, after downward motion, then upward positive, then downward negative. Therefore, we turn that into fourth quadrant. We need to continue same graph like this. Then here under gravity motion. Same inclination alpha, same inclination. Okay. Now here Vt graph of under gravity motion of particle. Initial velocity u upward, that is the case. So when you consider this one, initial velocity 0, no? So if I release this, then when you consider Vt graph, here time velocity, if I release this one, I'm going to take downward motion as positive. Then you need to sketch that one first quadrant. Initial velocity 0, then acceleration downward g, we can denote like this. Then tan alpha given by g. So in that graph, we have only first quadrant because that always moving downward. So if you consider the other one, initial velocity u, take here t, take here v, initial velocity u. Then I'll take downward motion positive. Therefore, from here, first quadrant, here angle alpha, here that motion graph. So anyway, first you have to think what is positive direction. First you have to think what is positive direction. Then we have to sketch the graph. Then upward positive, then downward negative. Negative goes to fourth quadrant. That's the thing. Now further you consider two object motions. So two object linear motions under gravity. Consider this one. Here you're gonna release this particle somewhere here. At same instant, I'm gonna project here with velocity u. Here particle A, particle B at t equals 0 position, then same vertical line. Okay. Now we have two particles. Anyway, each has downward gravitational acceleration g. Now here time, here velocity. So we have two directions now. Then let's take upward positive. Therefore here initial velocity u. So it can reach maximum height and it can move downward. No? Then initial velocity u. Here the motion alpha, here particle A. That's the motion. Then particle B, its initial velocity 0. Now I have taken upward positive, that moving downward, no? Then that goes to fourth quadrant. Then same acceleration, here acceleration represented by this inclination, no? Therefore second particle B start here and same gravitational acceleration, therefore that must be a parallel line, no? Same inclination alpha, here B. Start at rest with a gravitational acceleration downward. Here start with velocity u upward, then here maximum height, it goes downward. Okay. So anyway, these graphs are parallel. Opposite direction motions. Here first it goes upward, then this goes downward. Therefore first quadrant, fourth quadrant. So here maximum height. So after that maximum height, first particle goes downward, then here fourth quadrant, then B particle, that always downward motion, it continue, no? It continue. Therefore parallel lines, here fourth quadrant because negative regions, here positive first quadrant and fourth quadrant, that is positive direction, here negative direction. That's the thing. Okay. Anyway, you identify if we have opposite directions motions, definitely we have to sketch in first quadrant and fourth quadrant, opposite directions. Okay, we have to think that one. Okay. Further you see, okay, before that just write down topic, motion under gravity. Motion under gravity. Motion under gravity. Okay, right. Let a particle is projected vertically upward. Let a particle is projected vertically upward. Comma, downward, comma, or release from rest, or release from rest, or release from rest. The further motion is under gravity, and that is a linear motion, That is a linear motion. The object has always a gravitational acceleration. The object has always a gravitational acceleration, which is simple g within bracket 10 meters per square seconds or 9.8 meters per square seconds vertically downwards. Vertically downwards. Okay. Now you do with me. A particle released from rest. You sketch graph, time velocity, sketch with me. Here you take downward positive direction. Here it is alpha g, tan alpha g, Vt graph. Then you consider downward velocity u, positive direction, then time velocity, initial velocity u, here alpha, gravitational acceleration g, and tan alpha represent g. You consider upward motion u, it goes like this, take upward positive direction, then corresponding motion, time velocity, initial velocity u, here alpha, here upward, here downward, and tan alpha represent g. Okay, sketch them. Okay, now further you do with me. Put a stomach and write down. Let a particle is projected. Under gravity vertically upwards with initial velocity u. Okay. Now you sketch this one. Initial velocity u, same figure. So it goes like this. So here maximum height. Do with me. He acts at the maximum height, velocity 0. Here t equals 0, here t equals capital T, we call time of flight. Time of flight. Here let's take here this time t equals simple t1. At the maximum height, t equals simple t1. So I'll take here downward velocity v. So now here I'm gonna show you upward motion, downward motion, just like symmetrical. Then u equal u, v equal u, but direction opposite. Here upward time t1, downward time t1. I'm going to show that one. Okay. Okay. Now do with me. Do with me. Here time velocity. So you take here positive direction upward. Here initial velocity u, it goes like this. Here alpha velocity 0 position we call maximum height. V equals 0 position. We call maximum height. Then it's time t1. So I take here when it reaches the ground, let it velocity v, downward no, then you put minus v, minus c. Do with me. We know here bounded area with the time axis and the curve that represent displacement. Then here maximum height no, then this region capital H, maximum height, capital H, maximum height. This is maximum height, shaded region is the maximum height. Then that need to go downward, same displacement. Therefore here also same displacement, no? Same displacement H. Do with me. I'm going to label here O, A, B, C, D. Sketch them. Now, here tan alpha, write with me. Tan alpha value we know that is G. So we can write U divided by T1. U divided by T1. Therefore, T1 equal U divided by G. That is time to reach maximum height. Do with me. Yeah? Time to reach maximum height. Do with me. Then here shaded area OAB area, that is maximum height. Then H equal, here this area of the triangle, half times T1 times U. 1 over 2, T1 mean U over G, U. Then U square divided by 2G, here we call maximum height. Maximum height. Do up to that. When you are doing VT question, you have to remember gradient represents its acceleration or retardation, bounded area represents displacement. Okay. Okay. Now let's do this say. Then when you consider BDC part, DC area equal H now. Then H equal, again H value equal half times here V times, here let's take T2, here time T2, V times T2. So here velocity minus C, okay, velocity minus C, but you don't get minus value, just get only positive value. Then V times T2, here take 1, you write tan alpha again, here tan alpha equal V divided by T2, that is G V over T2. Then you write here V equal GT2, here second. Now take first term again, H value we know that U squared over 2G 1 over 2, V value, here V value GT2 times T2. Now you simplify, U squared equal, sorry, you better to put this on V2, half V T2 equal V over G. Then U squared equal V squared, then V equal U. Therefore, initially motion upward U, then when it reached the ground, its velocity downward U, downward U. Okay, prove that one. Okay, by this one you can say now V equal U, no? Then T2 equal V over G, V over G. Therefore, here T1 equal T2, T1 equal T2. Therefore, upward motion time equal downward motion time. Okay. Now with star mark write down. With star mark write down. With the above relation, we can discuss. With the above relation, we can discuss the upward motion is symmetrical with downward motion. Upward motion is symmetrical with downward motion. Therefore, when the particle reach the ground again, its velocity u vertically downward. Its velocity u vertically downwards. Its velocity u vertically downward. And also upward moving time is equal with downward moving time. Downward moving time. Okay. Go to another new line and write when a particle is projected, vertically upward, it has maximum height. It has maximum height. Then some height less than the maximum height. Comma, the particle pass twice. Okay. Now sketch with me. Here initial velocity u, same diagram, maximum height h. Now you think we know this h, that is u squared over 2g. No? Then you take some height level, simple h, so that is less than u squared over 2g. Then here t equals 0 position, here t equal time of flight. We know t equal 2u divided by g, no? So upward time u over g, downward time u over g. So we know that, no? Here upward time u over g, then downward time same, then u over g. Therefore total time 2u over g, then time of flight 2u over g. Now you consider you know them, then maximum height again we know. Okay. Then you consider here time t equal capital T1. So when it move upward T1, then you take here capital T equal T2. So if we denote time like this that mentioned, so the time has taken from the beginning. Okay, here T0 initial one. So here T equal T1, then T equal T2 mean total time. Then T equal capital T mean total time. Okay, here this notation represents that idea. So you take this level, height simple h, that less than u squared over 2g. So this is capital H now. Then some height less than maximum height has two different times. So when you consider that, here Vt graph, initial velocity u, it motion like this now. So I'm going to consider general one here. So let's take this time simple t. See this one clearly now. See this one. So let's take this height simple h. Therefore here this bounded area represents simple h. Okay. Let this velocity v. So here take velocity v. Okay. Then here time t. Then t has two possibilities. Simple t has two possibilities. Here this t has two possibilities. So upward motion t1, downward motion total time t2. Here two possibilities t1 and t2. So here this angle alpha, I'll do this way. So here tan alpha equal u minus v divided by t, no? This is g, u minus v divided by t. Here tan alpha u minus v divided by t. So here gt, u minus v equal u minus gt, take one. Now here bounded area, now it at this point, no? Then displacement simple h, that is h. Therefore, H value you can write here this area, trapezium, half into T into here U plus V, no? U plus V, here trapezium area. Then I'm going to remove here V, see 2H T U plus V equal U minus GT, cross multiply and replace V. Then simplify 2H 2UT minus GT squared. Take all into one side, GT square minus 2UT plus 2H. So see what we got. Here when you consider this one, we can see it is clearly quadratic type, no? Quadratic type, quadratic equation. So quadratic equation of time. So initially I told you there are two possibilities here. Because of this we can say we have two possibilities again. We have two different times. Then one root will be T1, the other root will be T2. We have two possibilities, T1 and T2. So here from T0 we have T1 time, T2 time. Here capital, not simple. Capital T1 and capital T2 time. So when the particle at that height, we have two cases, T1 and T2. Therefore, here quadratic equation, there are solutions. That solutions, capital T1, capital T2, no? Roots will be T1 and T2. So we know for quadratic equation, we have roots relation, T1 plus T2. T1 plus T2 minus B divided by A, then minus 2U divided by G. That is 2U divided by G. 2U divided by G, no? So now you see 2U divided by G, we know that is time of flight. Therefore here T1 plus T2 represent total time. Okay. So here T1 that equals to here this time, then T2 total time, and this addition full time of flight. Then anyway T1 plus T2 always periodic that time of flight. Then T1 plus T2 equal time of flight. Okay. So again when you consider T1, T2, here root sum, no? Similarly you write root product. T1, T2 root product. Then here sum, then product equals C divided by A. That is 2H divided by G, no? Here this is another relation. So you identify here that represent T1, T2, its addition given total time, periodic time. Here product given 2H divided by G. This one is important question type. Okay, do that one, complete it. Now you read 2003 ALL question. 2003 ALL question, read it. (2000) 2003 ALL question. Don't do read. Same question we have done here. Not this one. Here this part we have done. In previous case total time we have done. Then maximum height time again we have done. 2003 question. Okay, no need to do. We did that, no? Then mark it. We did that, okay? 2003. Okay, no need to do that now. Now you take 2005 A-level question. Now just read and start. 2005. 2005 A-level question. Read and start. We have two particles. Okay, you just read. Okay, sketch graph. If you have doubt, do with me. A particle A dropped from rest at height simple h. Yes, height simple h, particle A above the ground at t equals 0. Force vertically under gravity. At the same instant, another particle B is projected vertically upward from a point on the ground with velocity u. Here u. Okay, this is particle B at t equals 0, t equals 0. So we have to show they are in same level. Okay. Now here consider Vt graph, time, velocity. Here take here is displacement simple h no. Then I'll take upward positive, downward negative. Then initial velocity u. Here alpha that is particle B. This is for particle B. Then particle A is at rest first, then go downward, then negative, fourth quadrant. Here A. That's it. Now, a particle A dropped from rest height simple h above the ground at t0, force vertically down under gravity. At the same instant, another particle B is projected vertically upward from a point on the ground with velocity u. Draw Vt graph. Now it is done. Now using the diagram, velocity time graph, show that two particles are at same height from the ground at time h over u. Okay. Now here it moves downward and here this moves upward. So when they are at same level, then total displacement, here displacement sum will be h no. When they are at same level, here downward, here upward displacement, then total displacement h. Therefore you take here general time. Here take general time. Let's say simple t. Then here this one upward moving displacement, up here downward displacement. Then total displacement, that is simple h, no? Total displacement simple h. Therefore when you consider this area, say OA, BC area, OA, BC area equal h. Then write OA, BC, this is parallelogram, no? Then parallelogram area half into here this length u into no half value u into here perpendicular distance between parallel lines, that is t. Then t equal h divided by u. T equal h divided by u. And that is very simple question. Very simple question, but you have to identify the question real well. Okay. Okay, complete it. It's a very simple question, but you have to identify. Same question we have done another way. That means you can find upward displacement and you can find downward displacement, then take addition, that equal to h. But at once we can do that using the graph, no? At once we can do that using the graph. Complete it. Okay, so anyway you identify if there are 2 or 3 objects, any objects, so when they move under gravity, then all are parallel lines. All are parallel lines, no? All are parallel lines. Here the specialty, one is stay at rest first, then release, then the other one moving upward u. Then when they are at same level, then total displacement will be h. That's the thing. Okay, now read question 2014. 2014. Okay, then you start it. Two 2014. Okay, with that one you check this. So when you release a particle, then this acceleration downward chi, no? When you project upward that particle, its acceleration again downward chi. So if you project downward with velocity u, its acceleration again downward chi. Okay? So you consider here smooth plane. Smooth plane. So I'm gonna release particle, then its gravitational acceleration downward g. Then along this surface, it has acceleration g sine alpha. A equal g sine alpha. So smooth plane, we have g sine alpha acceleration. So if you release or if you project upward or downward anyway, its acceleration g sine alpha. G sine alpha. Okay. So here we can prove that one. You consider alpha. Here consider particle, its weight mg. Take reaction r. Then you take acceleration f. Here use f equals ma. Then here force mg sine alpha equal mf. Say this is f, mf. Then f equal g sine alpha. G sine alpha. Then you consider vertically its acceleration g, then along smooth surface its acceleration g sine alpha. You have component g sine alpha. Okay, you better to put note here. Put this note and you start section. Do alone. Do alone. Read this question and start 2014. So if you have any doubt, do with me. If you have any doubt, do with me. Now here it says that particle PQ are placed at point O on fixed smooth plane inclination alpha to the horizontal. 2014. Here it is. Take here O, two particles with inclination alpha to the horizontal. The particle P given velocity u upward. Here take P given upward velocity u, and here this is release. Here P and Q. Along the line of rate of slope through O. At the same instant, particle Q released from rest. Assume that two particles do not leave inclined plane. So it says that both particles move along on the plane. Sketch VT graph. Okay, Here we have to identify gravitational acceleration g, then its component g sine alpha. G sine alpha. Now, when we have two objects, definitely we have to think positive and negative directions. We have to think positive and negative directions. No? So, I'll take here upward positive, here downward negative. Whatever it is, okay. So, then initial velocity of particle P positive u. Then it goes maximum height, here maximum height. It goes like this, maximum height and come back. Then down, return motion like this. Then here alpha given, you take another angle beta here. Beta, we know tan beta value. Tan beta value, here acceleration, downward g sine alpha. No? It is g sine alpha. Then tan beta value g sine alpha. That is f, no? Tan beta value f. F equal g sine alpha. So here particle P. Then particle Q is at rest first. Then it motion downward, acceleration same, therefore sketch parallel line. Then same inclination beta. This is for Q. This is for Q. That is VT graph. So anyway, they are parallel lines, no? They are parallel lines. Using these graphs, show that the instant the particle P returns to the point O, when it comes back to O, the particle Q is at distance 2u squared over g sine alpha from O. So I'll take time here, simple t. So here maximum height. So when we have special property now, so here maximum displacement, then it come back. Then here upward time, here this way time, down time, both are same. Therefore, when you consider t, so same time we have to go back. So that instant we have to discuss, no? Then you take same time here t. Then first you find this time t. Then here upward, when it come to maximum displacement, its velocity 0. Then you take that time simple t. Then we have to come back again same time. So at that time we have to find the displacement of q. Okay. Therefore here tan beta g, g sine alpha, no? Then tan beta g sine alpha equal u over t. Then u given g non alpha given, then t equal u over g sine alpha. U over g sine alpha. Here time to reach maximum displacement along the plane. Then we have twice of that time, no? We have twice of that time. Now we need to find displacement of q. Displacement of q given by this shaded area, no? Here, shaded area, displacement of q. Therefore, displacement of q, you take shaded area. Here total time, simple t, 2t. Then triangle, no, half into 2t into, here find velocity, take velocity minus v. V. Then tv. Now we have to find v, no? Then again, same acceleration, take here this relation, then tan beta is acceleration, that is g sine alpha, equal, we need to find this velocity now, equal v divided by 2t. V divided by 2t. Always you have to write relations with gradients and displacement. Gradient and displacement. So you have to find this velocity, tan beta equal v divided by t. Then here t non v equal 2g sin alpha times t. Then t equal u over g sin alpha. U over g sin alpha. Then 2u, velocity 2u. Therefore, by star you find, say S equal TV, T equal u over g sin alpha, u over g sin alpha, V mean 2u. Then 2u squared over g sin alpha. U squared over g sin alpha, that is from O. So here you identify, so it's just like again motion under gravity, but along the surface, no? Motion under gravity along the surface. Then usually gravitational acceleration g. Now we have component g sin alpha. But anyway, upward motion is this. Here downward motion is this particle q. Then here when it reach maximum height, you can take time. Then same time we have to go back. Then same time you take. Okay. Therefore, by gradient relation, here gradient tan beta given by g sin alpha, that is u divided by t, find t value. Now t non. Then twice of that time we have to consider. Then at that time we have to find displacement of q. Here full this area given by displacement of q. Then right area, then we need this velocity, time we know. Then to find again this velocity, you get gradient relation. Then tan beta mean tan g sin alpha, no? Retardation, acceleration g sin alpha, no? Then by that you get velocity 2u, then s mean tv, substitute it. Okay, that 2014. (2011) question. Read and start. 2011 LL question. Read and start. Read well. (2011), if you have any doubt, do with me. A particle P is projected vertically upward from point O in space with velocity 2u. At the same instant, another particle Q projected vertically downward from O with same velocity u. So here O, particle P projected with velocity 2u. Then here Q, downward u. Both particles moves under gravity. Draw VT graph. I'll take upward positive. Here time velocity. So here particle P 2u. Here alpha particle P. The other one downward u, then minus u. Then same inclination alpha. Here particle Q. P and Q motion, no? Under gravity motion. Now further, both particles move under gravity. Draw VT graph of the motion. the particle p, q in same, show the speed of the particle q when the particle p reaches maximum height. So here particle p maximum height is here the position, here max height of p. So at the instant we have to find this velocity. We have to find this. Okay. Then here find this time first. Tan alpha, it is g now under gravity motion 2u over t. Then t equal 2u divided by g. Here the time. Therefore, again write tan alpha equal g. Here this displacement v minus u. Here we have negative value, but you consider only positive. V minus u. V minus u divided by time t. T. Then g t equal 2u over g. V minus u. V equal 3u. Here it is 3u, no? Complete it. Okay. Then you come to 2012 A-level question. 2012 A-level question. Read and start. All these are motion under gravity. All these are motion under gravity. So when you analyze in motion under gravity, you need to think gravitational acceleration g. So again, if you have two objects, you have to think positive and negative directions. So if the particle projects vertically upward, it has positive motion and negative motion, both it has, no? Then we have to think about the graph. So for VT graph always, we have two techniques to continue that. So gradient represents its acceleration, displacement represents its bounded area. Bounded area represented by displacement, and gradient represents its acceleration, no? Okay, go to 2012 A-level question. 2012 A-level question. Start. (2012). If you have doubt, do with me. So here given that particle is a particle p is projected at point O vertically upward under gravity with velocity u. Okay. 2012. A particle p project with initial velocity u. It moves like this. So let's sketch the graph. Here time, velocity, it moves like this. Alpha, let's take time here t. Then you first find that time. Tan alpha g, that is u over t. Then t equal u divided by g. U divided by g. Okay. Now here it is given that after time u over 2g. After time u over 2g means here this time now u over g. No? Then half of that, somewhere here, half of that, u over 2g. That's the time. Now it says that another particle q is projected at O, vertically upward with velocity v. So here time t equals 0. Here time t equal u over g. Then half of that, then you take here u over 2g, particle somewhere here. Then at same instant another particle q is projected with velocity v. That v value greater than u, no? Then at this instant, another particle is projected with initial velocity v. Then it moves under gravity. This is P, this is Q. That's how we sketch. Same inclination alpha, no? Both moves under gravity, no? Both moves under gravity. Here P, here Q. That's the graph. Now see, it says that let A be the highest point of the particle P reach. Here let highest point A. So that represents at this point. Draw VT graph. Using the VT graph, we have to show OA. OA means maximum height, no? Therefore, first one, OA represent here this area, here this shaded area, half into T into U, no? Half into T into U. T means U over G, then U squared over 2G. That is maximum height. Maximum height. Again, we have to show that V equal 5 over 4 and the velocity of the particle Q at the point A is 3 over 4. Do up to that. Now it says that they meet at that position. So at the maximum height they meet, no? So here the maximum height of A, then particle P, Q meet. Then when you consider here this shaded region, then they must be same, no? They must be same. When they meet, they start at same point. Therefore, when they meet, their displacement must be same, no? Therefore, here area, when they meet, you consider this area, that is OA, no? Here, again this shaded area same. You take here velocity v1. Then let's write here P A1, A2, A3, A4, A5, A6 area. Here A3. A1, A2, A3 area equal A4, here A4, no? A5, A6, A5, A6, A3. Here this area same, no? Okay, here one relation. Again, when you consider this, here this time, it is known, this time known, U over 2G, here U over G. Now find area relation. Then triangle area, that is U squared over 2G, no? U squared over 2G. Then trapezium area, half into, here this time, then U over 2G. U over 2G. Here this time U over 2G, V plus V1. V1. තනියම කරන්න. U over 2G. Okay, then simplify. Then here U equal V plus V1 divided by 2. By this you can get this. Again, V minus V1 over tan alpha, V minus V1 over, this is G now. Here U over 2G. U over 2G. Now further you simplify. Then U over 2, V minus V1. Then V1 equal V minus U over 2. Put it here. Then 2U, V minus U over 2. Then simplify. Here 2U plus U over 2 equal 2V. Then V equal 5. 5U over 4. V equal 5U over 4. So it says that they meet at the highest point of A, highest point of P. No? They meet at highest point of P. Here the highest point. Therefore, displacement of P and displacement of Q, they must be same. Then we can take that. So anyway, you always write acceleration relation and displacement relation. Complete. Then we have to find velocity of Q when it at A. That means V1 we have to find. Then here we need to find V1. V1 equal V minus U over 2. V mean 5U over 4. Then 3U over 4. Here the velocity. No? When it at A, we have to find velocity. Okay, further it says that when the particle Q at its highest position, we have to find displacement of P. Displacement of P, no? So here the highest position. So you take now time this time T1, take T1, then tan alpha equal V1 over T1, no? Tan alpha V1 over T1. Then you find first tan alpha V1 over T1 G. Then V1 known 3U over 4. Then T1 equal 3U over 4G. Here the corresponding time. So at this time we have to find displacement of P. So here maximum height, then thereafter downward motion, then you have to remove this part. Then displacement of P from O. So we know OA displacement, maximum height, then it goes maximum height, then come back now. Then U squared over 2G minus, here U squared over 2G, then you have to remove this area. Half into T1 into, here T1, you take corresponding time here, corresponding velocity V2 minus V2, then half into T1 into V2, then U squared over 2G, 1 over 2 T1, 3U over 4G into V2. Now you find similar V2 value. Then again take tan alpha G V2 over T1. Then V2 equal GT1 T1 3u over 4g. Here V2 value. This is V2 value. Okay. 3u over 4g. 3u over 4g. Now you substitute it here. U squared over 2g 1 over 2 3u over 4g V2 value 3u of 4. 3u of 4. Now simplify this. U squared over 2g minus 9u squared over 32g. 32g. Okay. Now just simplify. Just simplify this. Now here when you get common denominator 32, 16 minus 9, 7. 32g. 7 u squared over 32g. Okay. Complete. Step by step you have to think. First it says that the particle P is projected vertically upward. The particle P is projected vertically upward. Okay. So we know at the maximum height is time, that is u over g. Here when the particle is at maximum height, corresponding time u over g. U over g. So half of that time, then u over 2g, another particle q is projected with velocity v. With velocity v. Okay. Then half of that time, therefore while p moving, q is projected. No? Then finally said that they meet at the highest point of p. They say that says that they meet at the highest point of p. Then here the question. Then we have VT graph only two relations. One is gradient relation, the other one is displacement relation. No? We have to write different ways. Okay, complete it. Okay, let's have a small interval. Na? So up to now we have done especially all the things about linear motion. All the things about linear motion, especially motion under gravity, very special thing. So, but the analysis always we do with VT graph. No? For VT graph, we have to think about gradient relations and we have to think about displacement relation. Okay, gradient relation and area relation. That's the thing. Okay, we have to manage it. Okay, let's have small interval. Okay, let's start again. (2018) A-level question. 2018. Okay, start it. That is not under gravity one, but linear motion. 2018. First read it well. 2018. Do alone. You do alone. If you have any doubt, do with me. Others do alone. So lift moving in a mine pit of depth 4 meters, 4d meters. T equals 0 position. First acceleration g over 2 for d distance. Here g over 2 acceleration Another d distance moves with constant velocity. Then finally retardation. Another 2D retardation. Very simple question. Time velocity, here meters per second, here seconds. Acceleration for d displacement, uniform velocity for another d displacement, retardation for 2D displacement. Take alpha, beta. Here g by 2, take this velocity v, time duration t1, t2, t3. We have only displacement relation and gradient relations. Do alone, na? Do alone. No hurry, take your time. Tan alpha equal g by 2, that is v over t1. Then here take OA, BC, DE. OAE area, D, half into T1 into V. Then you take T1, 2V divided by G. Take V, G T1 over 2. Put it here. Then by that you can find T1. No? By this you can find T1. T square over 4. T1 2D divided by G root. Here V, G over 2 T1. dg root. Do alone. We have to find total time. Then next stage, constant velocity, d displacement, E, A, B, D area, D, VT2, VT2. T2. D over G. Then here retardation, then here tan B, DBC area 2D, half into T3 into V. 4D T3 into V dg root. 4 D over G root. Total time T1, T2, T3 addition. Here 4, 5, 7. Seven D over G root. That is 2018. Okay, then you come to 2007 A-level question. 2007. Start it. Always write gradient relation and displacement relation. Then you find unknowns. Here this case, acceleration given and three stages here, uniform acceleration, uniform velocity and retardation, no? Three stages. Therefore, you take time durations t1, t2, t3, time durations. Then here this time instantly velocity take v. Then usually we mark instant velocities and time durations. Usually we mark time durations and instant velocities. First you mark unknowns. Take time. – 2007. Here time velocity 10 start from rest, moves with constant acceleration 1/3. Alpha 1/3, reach velocity v, and then constant velocity, then finally retardation 1. Velocity meters per second, time second, total 432 meters. Then total time 1 minute, then 60 seconds. Then I'll take each stages time t1, t2 and t3. t1, t2, t3. Then here tan alpha equal 1/3 v over t1. Then t1 equal v 3v. Then tan beta equal 1 retardation, that is v over t3. Then t3 equal v. So in terms of v we can find it. Then t2 time total 60 no? Minus t1 plus t2, t1, t3. Then 4v, 60 minus 4v. Here constant velocity time, acceleration time, retardation time. Then full displacement given O, A, B, C. O, A, B, C area 432. Continue. You try alone. Then write full area relation. Trapezium no half into V into a total 60 T2. 4, 3, 2, 1 over 2V 60 T2 time, here 60 minus 4V. Now simplify. Sixty times 2, 4V. 216 V 30 minus V. Then expand 30V minus V squared. Then V square minus 30V 216. Then factorize this. We have two possibilities for V. 18, 12. V equal 12, V equal 18. We have two possible values for V. No? But when you consider 18 value, so when you put here 18 times 4, it is greater than 60. No? Then constant velocity time get negative. Then that won't happen because it is surely given there's constant velocity time. Therefore, when you consider 18, say T2 negative, contradiction, then here T2 positive, then this is the value. V equal 12 is the value. So here calculated one, no, T2 value calculated one. So when you get that 18, we get negative answer. That is impossible because actual case given, it has constant velocity, no? It has constant velocity. Okay, now we know V value. Now each stages we have to find displacement ratio. Then here displacement ratio half into T1 into V is to T2 into V is to half into T3 into V. Now here V cancel, T1 is to 2, T2 is to T3. T1 3V, here 60 minus 4V, T3 V. Then T2 value, V value 12, no? 12. Put 12 here. 3 times 12, 2, 60 minus 4 times 12, 12. Here 12 multiple cancel. 3 is to 2 is to 1. Then displacement ratio 3 is to 2 is to 1 each stage. Okay, then you come to 2021 A-level question. 2021. Okay, 2021. A particle P projected with velocity u vertically upward from point O reach point A after 4 seconds and come back to A again after another 2 seconds. Okay, let's see what is that. Here initial projection with velocity u. So it reached T, here T0, here T equal for A. Then after 2 seconds it come back. Then here upward time 1, here 4, no? Then here T equal 5, here T equal 6. So another 2 seconds come back. Then upward 1 second, downward 1 second. That is the thing. No? So initially it project with velocity u, after 4 seconds it reach A. Then another 2 seconds, it again come back, no? Then that happen upward motion, downward motion. This is symmetrical. Therefore, total time of flight for that 2 seconds. Now upward time take 1 second, downward time take 2 seconds. Sorry, another 1 second. So here it is. Here time in seconds. Here velocity meters per second. Here u alpha. So here first 4 seconds. Then here 5 seconds. Another 6. Here 6 seconds. Under gravity, you take here 10 in terms of g, no? Retardation g. Okay, that's the graph. Anyway, it is motion under gravity. Then initial velocity u, here the graph. So after 4 seconds, it reach A. Again after 2 seconds, thereafter 2 seconds, and thereafter 2 seconds it come back. Therefore upward 1 second, downward 1 second, because it is symmetrical. At the instant when the particle PSA for second time, that means at this position, another particle q is projected with velocity u. Here q, now here p. So at this instant, another particle q is projected. Then here it is. Here q, here p, same inclination. Hence find the value of u. Then let's write this say. Here 4 seconds now, here 5 seconds. Tan alpha g, u divided by 5, no? U of 5. Then say u equal 5g. Then 5 seconds now. Then u divided by 5 equal tan alpha, it is g, u equal 5g. Take here v1. Take here minus v2. Then here this displacement OA. This is OA, shaded area. OA. Trapezium area half into 4 into u plus v1 to u plus v1. Then further you find v1, then again write tan alpha relation. Let's write again. Tan alpha mean g, u minus v1 over 4. Here u minus v1 over 4. Then v1 equal here 4g u 5g, v1 equal g, no? 4g minus 5g g, v1 g. U mean 5g, v1 mean g, now it is 12g. OA displacement 12g. Better write units here. Units are given, then meters. Then here meters per second. First you have to analyze the actual thing. Then you manage it with VT graph. You have to think both. You have to think about actual relation and your graphical representation, that means VT graph. And the time taken by Q to collide with P. Okay, now when you consider this position, so now you take this position. So at this position, P is at A, Q is at here, O. So the after motion, it goes like this. Then when they meet, you consider here meet in position, here meet in time, take t. So here this displacement will be OA, no? So here downward motion, upward motion, when they meet, then total displacement here, that equal to OA. Then here shaded area equal to, again this shaded area. No? So when they meet, so at this position P is here and Q is here. When they meet, their total displacement OA. So when they meet, here OA displacement, here this area. Here u, no? You take V2. T times u plus V2. Here T times, here u plus V2. You find V2 value. Then by tan alpha again write V2 of 1. Then V2 equal G. Then put it here. OA 12G. T, u mean 5G. V2 mean G. Then T mean 2. T value 2. Then time taken to Q, 2 seconds. 2-second time will take to collide, no? So it take 2 seconds. Here Q start at 6, no? Then after 2 seconds they collide, no? After 2 seconds they collide. Okay, then you try 2001. 2001. Take time. Two 2001. Stationary police car observe a van traveling past it. Okay. Time velocity, get meters per second, here seconds. Here 72 kilometers per hour. 72 kilometers per hour. 72. Then simplify 20 meters per second. Then here van 20 meters per second velocity. 10 seconds later, police cars start pursuing it. Then 200 meters acceleration, take t, and then uniform velocity until it catch police car. Then 90 kilometers per hour. Then 90 convert into meters per second, 25 meters per second. So here meet in position, take time t. When they meet, their displacement same. When they meet, their displacement same. Now let's write few relations. Then 200 meters, let's take O, A, B, C, D, E, F. Then EFD area, 200 meters half into t into 25. Then t equals 16 seconds. Then police car acceleration time 16 seconds. Police car acceleration time 16 seconds. Because this displacement 200 now, 200. Now, if we need to find acceleration, tan alpha, acceleration of police car, 25 over t. Then 25 over 16 meters per square second. Here acceleration of the police car. Acceleration of the police car. So here we have to find total time taken to overtake the van. From the first encounter, that means total time. So anyway, when they meet, their displacement must be same because they start at same position. So when they meet here OABC area equal EFGC area. No? When they meet, their displacement must be same. So here van displacement area bounded by this van graph. Then here police car is this. Then 20 into 10 plus t plus t. 10 plus simple t plus capital T. Here police car displacement, first 200 meters acceleration, then uniform velocity 25 times t. Now they are same. Now here we don't know only capital T value, no? You can easily find capital T now. So identify when they meet, their displacement same, no? They meet at same position. So first encounter, same point, then meeting point again same. Now simplify. 200, 20 times t means 16, 20t, 225t. Then 5t equal 20 times 16, 64 seconds. Then total time, get addition, 10 plus t plus capital T. In 90 seconds, they meet. Okay, then last question for today, 2022. 2022, start it. Trial on. Two 2002. Here for first 20 seconds, 1500 meters. Sorry, 750 meters. Then next 30 seconds, again another 750 meters. Then t equal 20 mean from the beginning 20 seconds. Then t equal 50 mean from the beginning 50 seconds. Okay. Therefore here first 20, 750, next 30 again 750. Velocity is v1, v2. Here successive displacements. For successive displacement, anyway you try to write general relations. Displacements are given, no? So that instant velocities, take v1 and v2, you write displacement relations. Here this area, take O, A, B, C, D, E, F. OABF area 750, half into 20 into U plus V1, U plus V1 equals 75. Then similarly write this, FBCE area again 750, half into 30 into V1 plus V2. V1 plus V2 equal 50. So here we have only two equations now. We have only two equations but three unknowns. But we can create another equation by getting again full displacement. Okay. Or otherwise you subtract 1 minus 2. Then U plus V1 minus V1 plus V2. 75 minus 50. U minus V2 equal 25. U minus V2 mean here this length. Therefore, you can find easily retardation. Therefore, retardation equal U minus V2 over 50. 25 over 50, half. Meters per square seconds. Anyway, you identify here. So when you have successive displacements, you write displacement relation here, subject velocity. You do same thing here, subject velocity. Thereafter, by these two equations, you can get here this length. Now subtract them. Thereafter, you can write retardation. Now retardation known, then again you write full displacement. OACE area 1500. Then half into 50 into U plus V2. 1500. Third equation. Here third, here fourth. Now by these two we can solve the equation. Here the simplification little special. You better to remember at least some little thing. So here successive displacement, right area, again right area, then subtract, thereafter you take full displacement and take the value. Now we have two simultaneous equations solved there. Now here we have two simultaneous equations. Now we have to find here, the retardation is done now, and the velocity of the train at 50 seconds, that means we need to find. Then solve 4 minus 3. Then 2v2 equal 60 minus 25. 35. Then v2 equals 17.5 meters per second. Here the velocity 17.5 meters per second. So that's the velocity when it reach 50 seconds, when it comes to 50 seconds. The value of t when the train comes to rest. Then retardation same, no? You know v2. Take your time, simple t, same angle alpha. Then third one, you take tan alpha. So tan alpha means half, no? Retardation, no? Then v2 over t. Then t equal 2v2, 35 seconds. Therefore, total time 35 plus 50. So in 85 seconds, that comes to reds. So initially 50 seconds given, then another 35 will move, then total 85 seconds. Complete. Okay, that's all about linear motion for today.